To find a realistic planetary system, you might be better off looking at a fictional world like Tatooine rather than our own solar system. And if you want to understand how the very first black holes were forged, you simply have to look past collapsing stars and focus on the rapid implosion of invisible dark matter. Most of us learned a specific version of astronomy in middle school. We were taught that space is a predictable, mostly empty vacuum governed by clean, reliable mechanics. But data from modern space agencies now actively contradicts that consensus. The physical measurements no longer match the math in our textbooks. Today, we are examining 5 newly observed facts that contradict our foundational models of the universe. Let's start with how planets are born. The standard assumption is that you need a single, stable sun, like ours, for dust and gas to smoothly coalesce into a planet. But look at this comparative model. New simulation data shows binary star systems are actually ideal incubators for planetary formation. Overlapping gravitational waves from the two stars act like an egg beater, stirring the disk and rapidly accelerating how gas and dust clump to form giant planets. Multi-star environments appear to be the cosmic standard for building gas giants. Our isolated single-star solar system might actually be the anomaly. We also tend to view Mars as a completely mapped, geologically dead rock, with no chemical surprises left to find. Then, NASA's Curiosity rover drilled into the Martian surface and discovered complex organic molecules that had never been seen before on the planet. These specific carbon-based structures require dynamic chemical reactions to form. Their presence indicates that early Mars had a rich, varied chemical history, with liquid water actively interacting with volcanic rocks. Mars is an active chemical puzzle. The surface is littered with the exact raw materials required to support biological processes, elevating the mathematical odds that ancient life could have survived there. If you leave a planetary system and head into deep space, the assumption is that the void between stars is an empty, fiery vacuum. But NASA's SPHERICS mission is currently mapping massive, unimaginable regions of galactic ice drifting out in the absolute dark. These interstellar glaciers are composed of frozen carbon monoxide, solid carbon dioxide, and icy methanol, the chemical building blocks required for life. The empty space between star systems is actually a frozen reservoir. It preserves the exact organic ingredients necessary to seed entirely new worlds when they eventually crash into a forming solar system. We also assume that massive structures like the Milky Way taper off smoothly, with stars getting gradually further apart until they fade into the abyss. Plotting data reveals a hard boundary 40,000 light-years from the core, where starbirth inexplicably shuts down. As the graph shows, star formation holds steady across the disk, then flatlines entirely at the perimeter. We have no theoretical explanation for this. Our galaxy is constrained by an unexplained border wall that actively prevents gas clouds from collapsing to create new stars on the other side. Finally, physics dictates that supermassive black holes can only form from the gravitational collapse of massive, dying stars over millions of years. Yet, the James Webb Space Telescope recently peered into the early universe and spotted black holes that are mathematically impossible. They are simply too massive for their chronological age. Physicists propose a new model. Left, standard, slow stellar collapse. Right, early supermassive black holes forming from the rapid decay of dark matter. This bypasses stellar fuel entirely. Dark matter particles convert mass directly into a singularity, causing extreme, accelerated growth. It suggests that the most powerful gravity engines in the universe didn't start with stars at all, but were kickstarted by an invisible substance operating completely outside our known laws of physics. Modern astronomy is shifting from a process of cataloging known objects to one of revising our understanding of physics itself. The universe is a wild, rule-breaking machine characterized by hard, invisible borders, floating reservoirs of ice, and black holes powered by decaying dark matter. It's a reminder of our cosmic humility. Everything we confidently assume about space today is entirely vulnerable to being rewritten by tomorrow's data. Make sure to subscribe to stay updated as we track exactly how fast our understanding of the universe is changing. And let me know down in the comments, which of these 5 facts broke your brain the most?